Good morning, ladies and gentlemen. Today we are going to present Buzzsaw, an application that can boost exhibition entertainment capabilities. Exhibitions are one of the interesting ways to get a bit closer to the art. Nevertheless, they usually don't get much of the attention due to many reasons. One of them is staticity. Visitors can only look at the paintings but cannot change it. Thus, museums have less guests and less support correspondingly. Yet there is a solution. Buzzsaw is an application more suitable for mobile phones with cameras. Its structure can be decomposed in these 4 steps. In simple terms, users can try different styles on a shot of the painting and imagine how it would look like if it was painted by Salvador Dali, for example. This way, they become artists by themselves. They can shoot within different angles and distances and still get a clean styled painting or back projected one if they want so.
Now, our dataset for the project contains 15 images. We divided them into 5 images for training the algorithm and 10 images for testing it. The dataset has the following attributes. Paintings should cover more than 20% of total image size. They should not be partially covered by any other object or humans. Paintings should have only slight angular displacement. Our pipeline starts with painting detection and extraction from a given photo. This step was done using contours. Also, removing paintings frames was achieved using contour attributes such as area and hierarchy. After we apply the style transfer process, we need to do the inverse transformation to have the modified painting inside its frame in the original image. And here we explore 2 approaches. First, by computing the inverse of the projection matrix, which gives a close but not a good approximation due to the pseudo-inverse accuracy limitations. Second approach, we exchange between the original source points and destination points and then forward it to the same projective transformation. And it worked perfectly, as we can see on the bottom image.
What is style? Style is just an image that inherits some outstanding features of a specific artist or architecture style. Here is a subtle outline of how style transfer proposed in this paper works. And the essential part here is a pre-trained on ImageNet DGG19 network that can extract representative features from triplets of images. First is the original image, second, the style, and the third one, noise, the one that is optimized during the style transfer process, and eventually will become a styled painting. We use extracted features to form the loss. Content loss is just the difference between current generated features and original ones. Style loss is the difference between gram matrices for style and generated features. Alpha and beta are just hyperparameters. Now let's see some of what we got. Well, detection is not always correct, but still seems reasonable and can be actually interpreted as a different piece of art, you know?
Here we can see a bad example of detection. The frame was not removed completely. Evaluation criteria for both detection and inverse transformation is intersection over union. We compare the ground truth kernel with the detection kernel, and we also compare the ground truth kernel with the inverse kernel. The plots here show intersection over union accuracy across training and testing sets. We can see on the left that the accuracy for both processes is high and always larger than 70% for training. For testing set, we have also the same high level of accuracy, except for one image where accuracy drops. Now, to sum up the evaluation, we have average accuracy of more than 96 on the training set and more than 88% on testing set.
This solution is not a unique one, of course. Here are two more algorithms that can be employed for the same task. Deep photo style transfer is essentially the next step of the implemented algorithm. This work implies affinity constraints in the color space and yields more realistic output. Another approach is a Sinkhorn algorithm from the optimal transport theory. It is not deep learn-based approach, but still can efficiently transfer the colors between images. But it is not that good in a style sense. Actually, we have implemented the Sinkhorn color transfer approach in our NLA project, and it is quite good, but still not as stylish as we want it to be. Here's the conclusion. Our project can boost exhibition business and involve more people into the art, definitely. Yet, there is still much room for the improvement. And the highlights here is that, first of all, some museums can be overcrowded. And the visitor, for example, cannot take like clear image of a painting. So we should make some algorithm for the people removal to experience for our users. Also, we can employ different approaches, like from the previous slides, deep photo style transfer. And also, we have to note that this algorithm, implemented algorithm, is not so fast. It takes around 20 minutes per image on Colab. Thank you for the attention, and here are the papers. There you can learn more about this topic. Goodbye.